So let's continue this right here. Let's put this in reduced row echelon form, and we're going to get our last row is going to look like this. A -2 here, a 1 here, and a 1 here. So to put this in reduced row echelon form, I have a 1. I'm looking at this bottom one right here. I know this is getting kind of messy. I want to get a 0 right there. So what I'm going to do, I'm going to take a -1 times row 3 and add it to row 2. So the bottom row stays the same. 0, 0, 1, 0. So if I take a -1 times 0, of course it's 0. You add it to the second row, you get 0. And then the same thing, and take 0 times 0 and add it to the second row. Here you get 1. So right here, I'm going to take -1 times that 1 right there. I get -1. Add it to this 1 right there. You get 0. I messed up here, huh? This is a 1. That's a 1 right there. So I'm going to take -1 times 1 right here. Add it to this 2. I get 1. So I take -1 times 1, add it to this 2 over here on the left, and you get 1, which is what you want, right? And then the top row, I want to get let me circle this over here. Okay, this top row right there, you want to get a 0 here. You already have a 0 here, and then that'll be your answer. So if I take row 2 times, I got a 3 here, -3 here. If I take row 2 right here, if I take 3 times row 2, add it to row 1, it's going to give me a 0 there. So take 3 times 0, add it to 1, you get 1. 3 times this 1 right here, added to -3 gives you 0. So 3 times 0, 0, added to 0, 0. So here you go. Get 3 times 1, which is 3. Added to that -5 gives you -2, which was what we wanted. So see that last row? You have -2, 1, and 1. So this is your Z value, that's your Y value, and that's your X value. So that's called reduced row echelon form. Pretty cool. Main diagonal is 1. You got 0s above it and 0s below. Well, let's look at using the calculator to do this. I already typed some stuff in here. So if you go to second matrix right there, and then if you go over to edit, this is going to edit A. If you go down, that's going to edit B. So I'm going to edit A. I'm going to hit enter. And what I'm going to type in here is I'm going to type in the original system of equations. And I already did it. See this? The 2 right there is your x. So it's 2x minus 5y. Let's just look at it. It's a 3. The first number is, it's 3. That's the number of rows by 4 columns. Then you type in, there's your x coefficient. I'm looking at the top row. It's 2x, so you put a 2 in there. And it's minus 5y, so you put a minus 5 in there. And then it's 1z, so you put a 1 in there. And then the answer is 8. So just go through and put all this in here, right? And then what you do is, I'm going to hit second matrix again. And I'm going to do some math. So edit over to math. All sorts of great things in here. You can scroll up or scroll down. If I scroll up, that right there is row echelon form. That right there is reduced row echelon form. So if you hit enter, RREF, reduced row echelon form for matrix A. Hit enter. That takes away all that work on the left hand side right there. See that? So last row, negative 2, 1, and 1. So that's reduced row echelon form on your calculator. Pretty slick. Okay, last thing I want to show is solving this by using what's called a matrix equation. So what I'm going to do is I'm going to take my coefficient matrix, which would be just the coefficients, 2, negative 5, 1, negative 1, 1, negative 1, and then that last row I got 1x minus 3y plus 0z, so put a 0 there. So that's your coefficient matrix. We're going to call this B. And then you put your variable matrix, x, y, z. That's your variable. And then if you multiply those two together, you're going to get your answer matrix. Answer, which is just negative 8, 2, and negative 5. So I'm going to call this, I'll call that X for a variable matrix, and I'll call this C. So I have BX, B times X equals C. We can do this on a calculator. What we're going to use is the inverse matrix. So if I take the inverse of matrix B times B, that's going to give me the identity matrix. The identity matrix has to be a square matrix. Main diagonal will be 1s, and then you have zeros above and zeros below. That's the identity matrix. 1 on the main diagonal, zeros above and zeros below. So if I find the inverse of the coefficient matrix, this is the notation for it, and if I take that times my matrix B, which is the coefficient matrix, I'll end up with the identity matrix. And if you take the identity matrix times matrix X, it's going to leave you with just matrix X. So I'm going to take the other side times the inverse matrix of B. So I'm going to take the inverse matrix of B times matrix C. And what that's going to do, it's going to give me the answers. Now the inverse of matrix B is a 3 by 3. Matrix C right here is a 3 by 1. So whenever you multiply matrices, those have to be equal. And then this will be your answer right here. Your answer is going to be a 3 by 1. So when you're working with matrices, you have what's called a matrix is just an array of numbers. So this is A11, this is A12, this is A13, and so forth and so on. This is A21, this is A22, this is A23. So the first number, those subscripts, the first number is the row, the second number is the column. So this is row 2, column 1. This is row 2, column 3. So this position of this 8 right here, that's row 1, column 1, right? That 2 right there is row 2, column 1. That minus 5 is row 3, column 1. That tells you how to multiply a matrix. So to get that negative 8 right there, I'm going to multiply row 1 right here times row 2. I'm sorry. I'm going to take row 1 times column 1, and it's going to equal 8. So if I do that, if I take row 1 times column times this column 1 and it equals negative 8, I get that. Get my top equation. If I take row 2 right here, take row 2 times column 1, take row 2 times column 1, you get that equation. Take row 3 times column, did I say it wrong? Take row 2 times column, I'm sorry, yeah. Take row 2 times column 1 and you end up with the second equation. Take row 3 times column 1 and you end up with that last equation. So that's just a review on how multiplying matrices work. The reason I wanted to show that is because you can't do this. You can't go matrix C times the inverse of matrix B, because C is a 3 by 1 and matrix B is a 3 by 3. These have to match up. You can't multiply them together, right? So the multiplication with matrices is not commutative. So it's got to be like that. Anyway, so let's look at the calculator again. It's pretty slick. So this is the answer right here. Right there. That's how you solve a matrix equation. So I already put in the calculator. Let's clear this out. I'm going to go second matrix, and let's look at 2. See right there? 2, negative 5, 1. Negative 1, 1, negative 1. That's my coefficient matrix. And if I do second matrix and go to 3, matrix C, that's my answer matrix. So if we do the inverse of matrix B, how you do that? You go second matrix 2, matrix B, and I'm going to take this button right here, -1 button. That's the notation for the inverse of a matrix. So that takes the inverse of the matrix. And then what I want to do is I want to multiply that times matrix C. So I hit second matrix there and hit 3 for C. And notice how it matches up what I have on the left, and hit enter. There's your answers. Negative 2, 1, 1. So the top number, this is your answer matrix, and the top number is your X, second number is your Y, third number is your C variable. So that concludes this broadcast, this recording. So I showed how to solve a system of equations. The last thing we did is using the inverse matrix. So you have a matrix equation, you got to multiply by the inverse of the coefficient matrix. All you got to do is take the inverse of the coefficient matrix times the answer matrix, and you'll get the answer. And then really slick way to do it is the middle thing we talked about was row echelon form and reduced row echelon form. There's buttons on your calculator. A really quick way to do that. And the first thing we showed was how to do all that by hand. So you'll love this. You'll love using your calculator on this stuff.